Greetings, M Squared here. Today we're going to talk about each of the 5 ways of solving quadratic equations that we've learned. We're going to do an example of each, and then your homework will be doing all 5 of those because that is what's going to be on your test coming up. So we're going to start with graphing. We have a graph here. How can I graph this? Well, there were a couple ways, right? We could use completing the square to change this into vertex form, which is what I'm going to do because that's what I'm hoping you would do if you had a problem like this. But remember, we also learned that you could take negative b over 2, and you could find that, you could plug it back in and find the vertex. You can look in your notes for that. I'm not going to do it that way, but you can. So I'm going to say x squared minus 6x, I'm going to leave a little room, plus 5 equals, I'm going to just put a y here for now. It's 0 when you're solving, it's y when you're graphing. And since I'm graphing, I'm just going to put the y there. So what did you do? You took half of this, which is 3, squared it, which is 9, and added it here and subtracted it here. Remember, we're doing it all to the one side, so we have to add it and then subtract it. So then I get x minus 3 squared minus 4 equals y. Remember, I'm solving it, but I want to graph it first. So that tells us what our vertex is, right? Our vertex is 3, negative 4, so I'm going to go over 3 and down 4. And then I'm going to remember that A is 1, so my pattern is 1. So my pattern is 1, 3, 5. So that means when I go over 1, I go up 1 on both sides. And then if I go over 1 more, I go up 3 more. And remember, I'm solving by graphing, which means I'm trying to find the x-intercepts. And it looks like they're right there. So my solutions are x equals 1 or 2, 3, 4, 5. Those are my answers solving from the graph. Now remember, we also wrote that as 1, 0, and 5, 0. Depends on how they want you to write it. So that is solving by graphing. When we were solving by graphing, we also learned about a table. So the next example is going to be of a table. So here I have a quadratic equation. It's already in vertex form, which is nice because I know that my vertex is 3, 8. And I'm going to use that, and I'm going to use my pattern. Remember, when we used our pattern and we went over 1, we went up 2, or down 2, it should be. So I'm thinking this is 6, right, using my pattern. But let's go ahead and put the 2 in because I want to show you how that works. So you're going to put 2 in right here. What's 2 minus 3? Negative 1 squared. 1 times negative 2, negative 2, plus 8, 6. So all I did was I found f of 1, right? I'm sorry, f of 2, and I got negative 2, 2 minus 3 squared plus 8, and I just figured that out, and it was 6. If I went over 1 more, remember, if my original is 1, 3, 5 pattern, but if a is 2, that's for a is 1, then it's going to be 2, 6, 10. So let's see, if I go down 6 more, since it's negative, I would be at 0. If I went down 6 more, I would be at 0. So let's check it out. If I put a 1 in here, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. Plus 8 would be 0. And I just found my answers, 1 and 5. Those are my x-intercepts. So solve by making a table of values. I just did. My answers are 1 or 5. Okay, next factoring. It's been a while since we factored maybe. So remember, when we factor, we want to get it in standard form first. So I'm going to move the 10x over. It's a binomial, and I'm missing c. So I know there's a greatest common factor because x is just staring at us, right? So x is the greatest common factor, and taking out the greatest common factor is always the first step. It doesn't mean you always have a greatest common factor, but if there is one, you always want to take it out first. So once I do that, I factor it, then I set each factor equal to 0. Whoops, that should have been a minus 10 equals 0. So then x equals 0 or 10, because if I add 10 to both sides, I get x equals 10. So there's that one. And now to factor this one, I will go like this. So 2x and x, right? That's 2x times x is 2x squared. So we use different methods when we factored. So it depends on what method you used. You might have used the box method, but we're trying to find 2 factors of negative 30 that add up to negative 7. And that looks like a negative 10 and a positive 3. So that means one way I want a 10 and one way I want a 3. So the 3 and the 5 are going to have to go like that. That gets me my 15, right? But this gets me my 10, and this gets me my 3. And I needed a negative 10 and a positive 3. So that's the factors of it, but then I have to set each factor equal to 0. And you might have learned a different way of factoring. 2x plus 3 equals 0. So I subtract 3 from both sides. 2x equals negative 3, then I divide by 2. So x equals, I'll put it down here, x equals negative 3/2 is 1. Remember, the shortcut was just to take the opposite of this over that, but if you set each one equal to 0, you get that. So I'd add 5 to both sides. So x equals 5, so those are my solutions when I factor. Okay, so we've done graphing, we've done factoring. 3 more to go. Using square roots. So in our first square root, we had 2 kinds that we did. We had one where there was no b term and one where there was, but it was kind of hidden in this binomial squared kind of thing. So whatever the case is, we get the x squared or the squared thing alone. So that means I add 42 to both sides. So x squared equals, that gets me a 0, that gets me a 0, that gets me a 4, so 400. Take the square root of both sides, and we'll check for negatives. It wasn't negative, so I know there's a solution. So x equals plus or minus 20, or 20 or negative 20, because the square root of 400 is 20. Over here, again, I get the squared thing alone. So I get x plus 5 squared equals 12. Then I would square root both sides. There went my pen. So x plus 5. Remember, the squared and the square root always cancel out. Equals plus or minus the square root of 12. And that is going to be irrational because 12 doesn't have a perfect square. But remember, we want to get it into simplest radical form. So I'm just going to, before I move the 5 over, I'm just going to do that. 12 is 4 times 3, and 4 is a perfect square. So I know it's going to be 2 square roots of 3. And then I'll subtract 5 from both sides. So my final exact answer would be negative 5 plus or minus 2 square roots of 3. We're not going to round. We're just using the exact answer. Okay, the fourth way we learned was completing the square. And completing the square, we first going to give us some room here. Remember, we want some room so we can add what we need to right here to complete this perfect trinomial square. And how we do that is we take half of 10, which is negative 5, and we square it, which is positive 25, and we add it to both sides. And then we factored the left side. That's a 5. Sorry, it doesn't look much like a 5. And what is that? 71. And we are going to then square root both sides. And when we square root again, this becomes just like what we did up here. So that's kind of cool. That's why we learned this first before we learn this, because that makes it easier. So we get x minus 5, those cancel each other out, equals plus or minus the square root of 71. And that is not a perfect square, and it doesn't have any perfect square factors in it. So x equals, when we add 5 to both sides, 5 plus or minus the square root of 71 as our exact answer. Okay, and finally we did quadratic formula, which is fresh in your brain hopefully, because we just got done doing that. We make sure it's in standard form. A equals negative 5, B equals 4, C equals 12, and then we sing our song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Then we find our discriminant and figure out what that means. So we've got a negative and a negative here, so we know that those two are going to become a positive. So we've got a 20 times 12, and then we have to add it to 16. And when we do that, we get 256, and that is a lovely perfect square. So we're going to get so it's positive and it's a perfect square, which means that we're going to get 2 rational roots. So the square root of 256 is 16. So we're going to get negative 4 plus 16. That's going to get us a 12 over negative 10. And then we're going to get, the other one is going to be negative 4 minus 16, which is negative 20 over negative 10. So those are our 2 answers. This gets me a 2. And this, 2 goes into there 5 times, 2 goes into there 6 times. So this gets me a negative 6/5, or we're going to keep them as fractions. If you like decimals better, you can do decimals. And those are the 5 ways. So in tonight's assignment, you're going to have to solve quadratic equations all 5 ways. So hopefully you have good notes and you've memorized that formula. Okay, good luck. M squared signing out.